Okay, ladies and gentlemen, this is mainly for period 2, or maybe for anyone in period 1 that missed Friday's class. So there's a handout that was given, and it looks like this. It's actually not unit 3, we're actually talking about unit 4, and it's transformations of functions. And what's going to happen here is I'm going to go over these examples with you. Now this sheet is in your workbook, but it may be a little bit different. In fact, I'm pretty sure that it is. So if you didn't get a copy of this in class, I will attach it as an attachment to the bottom of this post so that you'll be able to pick that up. But to be honest with you, I don't think you need it. You can just write out the examples on another piece of paper and we'll go from there. So let's start off. We're going to talk about function notation, f of x, and we've talked about this before. This is your old grade 9 notation, y equals 4x plus 1. Function notation, we're going to have f of x, and this is a statement saying that our function is called f, and it's going to be expressed in terms of the variable x. So what that means is that it's a way of talking, it's a language. It makes it much easier to write something. So then something like this, f of negative 3, actually means evaluate the function when x equals negative 3. So what that means is figure out the range value when the domain value is 3. So what happens is we put in negative 3 for x, and then we evaluate this function. 4 times 3 is negative 12, plus 1 is negative 11, and you're done. That's it. That's all there is to it. So let's go over a few of these and see how easy this can be. So I've got a function, and they're telling me that it's f equals 2x squared plus 1. So f of negative 5, therefore, is going to mean that I take negative 5 and put it in everywhere there's an x. Notice that this says evaluate the function f. That's this function, not this function. That one's g. This one's f. And we're going to do it when x equals negative 5. Now, using order of operations, it's negative 5 squared is 25 times 2 is 50 minus 1 is 49. Over here, now we're changing it up a little bit. We're talking about the function g, so I'm going to use this one. That's the function g, and it means everywhere that there was an x, please put in a 7, and then evaluate that. So that's going to be 21 minus 1 is 20. That's all there is to it. It really is not complicated. Now, I can make it look a little bit more complicated, but everything stays the same. What this says is take f, this guy, and everywhere there's an x, put in x plus 1. So this is now going to be f of x plus 1 equals 2, instead of an x, it's x plus 1 squared minus 1. And we work that out, and it's x squared plus 2x plus 1 minus 1. So it's 2x squared plus 4x. That's going to be 2 minus 1. So it's going to be plus 1. So 2x squared, 4x, plus 2, minus 1, plus 1. And over here, so it's g of 2n minus 4. So instead of putting in an x, we're going to put in a 2n minus 4. Now we still need the negative 1 here because, look, there's still a negative 1 here. So this is going to be 6n minus 12 minus 1. So 6n minus 13. There you go. That's the first page. All done. Pretty simple. Let's take a look at the second page. Well, now we got something interesting, but it's a matter of reading it. Can you read it? This says g of 2 goes in for f. So what I would do is I'd figure out what g of 2 means. So g of 2, going back to our old value for g, which is 3x minus 1. So it'll be 3 times 2 minus 1, which is 5. So therefore, f of g of 2, now g of 2 equals 5, so that's going to be f of 5. Then we put in f of 5, and remember that f is 2x squared. So it's 5 squared minus 1. 5 squared is 25, times 2 is 50, minus 1 is 49. And you're done. So the answer to this is 49. And I went through some steps to get it. What does this say? This says find f of 4 and then subtract g of negative 3. Basically, it's a big subtraction question. So we'll figure out f of 4 first. And f of 4 is going to be 2, 4 squared minus 1, which is 16 times 2 is 32, is 31. And g of negative 3 is 3, I think. I'm looking back. Yep. Negative 3 minus 1. So it's negative 9, take away 1, so it's negative 10. So therefore, f of 4 minus g of negative 3 is simply going to be 31 minus negative 10, which is going to be 41. That's all there is to it. This one, you should be getting good at this point. F of 3 times negative 2. So negative 2, now f of 3 is, if I remember correctly, 2. 3 squared minus 1. So this is negative 2 times f of 3. Using order of operations, we're going to work in here. So that's 9 times 2 is 18. That's 17. Which is going to equal negative 34. All right, number 2. If g of x equals this, find the value of x that makes g of x equal to 34. So they want to know for what values will g of x equals 34, and you know that g of x equals 3x minus 8. So basically what they're saying is 3x minus 8 equals 34. And they want you to solve that because they're after the values of x. So that'll be 3x equals 42, and so it'll be x equals 42 divided by 3. And I think that works out to 14. Number 3, f of x equals this, g of x equals that. For what value of x will f of x equals g of x? So that's going to equal that. That's going to equal that. Rearrange it. Remembering how to solve a quadratic. Remembering how to factor. Therefore, either x minus 6 equals 0, in which case x equals 6, or x minus 2 equals 0, x equals 2. That's it. So your homework, now if you weren't here, you didn't pick up your textbook, so you're not going to be able to do that part. But you can certainly do this. These guys, here's some answer. These guys, here's an answer. This guy, here's an answer. And maybe you can give a friend a call who does have a textbook, and you can get them to take a picture of this section, and then you can do these. And if not, then it'll be part of your homework on Monday to get you caught up on. Okay, guys, have a good weekend. We'll see you soon.